So I kind of forgot how to means like these expression and these points basically. So I want to focus you on these 2 points. A XOR B means A B bar plus A bar B. This is how you open. Okay, whenever you see two inputs getting XORed, this is how you can imagine. This is how in Boolean expression you can write or you can say it. You can open it. Okay, A XOR B will be A B bar, where B bar is the complemented form of B. Okay, this is how we denote complement. Then plus A bar B. Okay, similarly A XOR B will be equal to A bar B bar plus AB. This is how you open it, both the quantity. Now XOR, just like XOR is inequality and anti-coincidence gate, XNOR is equality detector and coincidence gate. You have seen the truth table and all. Now we will be using this two property to generate some other properties, important properties regarding XOR and XNOR. Okay. Now there is a relation between XNOR and XOR gate. So whenever you will have odd number of inputs, so you can see here A, B, C, 3 inputs are there, which means odd number of inputs. Then you can follow this expression. A XOR B XOR C will be equal to A XNOR B XNOR C. Okay, whenever you have any number of odd number of inputs, then this is how it will be valid. Okay, even if you will have 5 number of inputs, let's say A XOR B XOR C XOR D XOR E will be equal to A XNOR B XNOR C XNOR D XNOR E. Okay, this is how it follows, and it can go for any number of odd number of inputs. Okay, and if you will have even number of inputs, here you can see A B C D, 4 inputs are there, which means even. So here this relation is being followed. Okay, A XOR B XOR C XOR D bar will be equal to A XOR B XOR C XOR D. Similarly, you can go for 6 as well. A to A XOR till B C D E F, so F bar will be equal to A XOR, you can go till F. Okay, so that is how means they are related. Sometimes it is being asked, and you can see that even if you will open this expression, no, that A B bar plus A bar B types, then doing the XOR with C, doing the XOR with C, and if you will open this as well, you will get the same expression. But the pain is too much, right? Means like it consumes too much time to actually expand it, both the expression, and see whether they are equal or not. So instead you should remember these properties. So in case of even, there will be a bar. In case of odd, there won't be a bar. Okay, so yeah. Okay, let's look at some more properties. So now you know how to open this expression XNOR and XOR. What you can see is if you will XOR A with 0, that is bit 0, or you can see logic low 0, then what you will get, you can expand whatever we know, A bar 0 plus 0 bar A. This is how we expand this, and you can see here 0 bar means complement of 0, that is 1. 1 ANDed with A will give you A, and 0 ANDed with A bar will give you 0. So 0 plus A will give you A. Okay, so AND and OR properties are being applied, and complement also it's being applied. Similarly, you can have A XOR 1 will give you A 1 bar plus 1 A bar. This will be A bar. Similarly, if you will XOR A with A, you will get 0. A with A bar, you will get 1. You can expand this. Okay, just apply this property whatever we have seen. Similarly, this was for XOR. For XNOR, you can see here A XNOR 0 will give you A bar. So this is how you expand. A bar 0 bar plus A 0. Okay, 0 bar will give you 1. 1 dot A bar will be A bar plus 0 into A will be 0. So that is how you get A bar. Similarly, A XNOR 1 if you will do, you will get A. A XNOR A will give you 1. A XNOR A bar will give you 0. This is how you can imagine. This is XOR gate and you are giving one input A and another input 0 if you have to implement this, and that is what you are getting at the output. Similarly here you can imagine in this fashion, A 0 XNOR A bar. Okay, that's how these are very small properties, but we will see how it is being implemented, okay, in future. So yeah, let's look at some more properties. This one is one and this is another one. A XOR 0 is, we know, A, and A XOR A we know 0. So can we say that if I replace these two guys, I will get this? Okay, so means we can replace these two terms. Okay, so what I can generate is, if A XOR B is equal to C, means we can replace these two. So A XOR C is equal to B. Similarly, if B XOR A is equal to C, we can replace these two terms and we will get B XOR C is equal to A. Okay, this is one property, this one. Then another property here, if you will see, if A XOR A goes till n terms, then what will be the result? What we know is A XOR A is equal to 0. So you can imagine 0 XOR 0 XOR 0 dot dot till n terms. Okay, how you gonna solve it? Well, let's take an example. A XOR A XOR A. If we have three terms, let's say three terms, A XOR A XOR A. A XOR A is 0, so this can be written as 0 XOR A, and 0 XOR A is A. Okay, now if I will take A four terms, if I will take four terms, A XOR A XOR A XOR A, if we will take four terms, then this will be 0 XOR 0. How? Because this guy will give 1 0, this guys will give 1 0 because of this property. So 0 XOR 0 will be 0 because it's an inequality detector. Okay, so they are equal, hence output is 0. So what I can conclude here is, if the number of terms is odd, the output will be A. If the number of terms will be even, the output will be 0. Okay, so that's how we will solve. Odd A, even 0. So if n is equal to odd, this answer will be A, and if n is equal to even, then the answer will be 0. Okay, so this expression will be A and this expression will be 0. So clearly you can't open each and every expression, it will take a lot of time. Even if it will give you A XOR A till 7 terms, if they will give, then it is very tedious task to open them. Like A bar plus A bar A, you keep on A bar A, you keep on doing this and it will consume a lot of time. It's better you generalize it with odd and even number. Okay, how many terms are there, odd terms or even terms, and depending upon that you will have either A output or either 0 output. Okay, so this is one another property. Let's look at few more properties. So A bar, if you will do A bar XOR B, instead of A XOR B you are doing A XOR B, A bar XOR B, this will be equal to A XOR B. Okay, this is how you can see A double bar B plus A bar B bar. This is how you expand this. A double bar will be equal to A only, so you are complementing 2 times a number, so you will get the same number, A dot B plus A bar B bar. Okay, this is exactly similar expression if you will open this A XOR B. On the similar note, you can have these two properties as well. So A XOR B bar will be equal to A XOR B, and A bar XOR B bar will be equal to A XOR B. Okay, so this you can even prove if you want. So A B bar double bar plus A bar B A B bar plus A bar B double bar, this will give you A B bar plus A bar B, which is same as this guy. Okay, similarly here also A bar B double bar plus A double bar B bar, this will give you A bar B plus A B bar, which is same as this guy. Okay, so these are some short properties I just wanted to mention. Okay, let's look at this important example. The way people can ask question. These small properties may look easy, but this is how to confuse you a question is given. So 1 and A are the input to the one XOR gate. The output of this XOR gate will be given to the another one, whereas this input is common, A is given along with the output of these XOR gate. Then these two's output will be given to another XOR gate with A as it is. Okay, so again if you will go, this A will be carry forward and this will be given to another n. It goes till n number of gates. Then what will be the output finally? This is what you have to calculate. So directly apply this property. So we know that 1 XOR A is equal to A bar. So here A bar will come. Okay, now you are XORing A XOR A bar. This A is here, this is A bar, this will give you 0. Sorry, this will give you 1. So here it will be 1. Then again you are XORing 1 and A. This is A, this is also A. So 1 XOR A is A bar. So the output will be A bar. So what you can generalize is, for this, if you will take only one gate, you will have A bar output. If you get 2 gates, you will have output 1. So you can generalize it. If n is equal to odd, again because third number it is giving you A bar, so n is equal to odd, the output will be A bar, and if n is equal to even, the output will be 1. Okay, so that's how you can generalize. So just a small means like confusion to create this kind of question is framed. Really what we have to apply is even, odd and these small properties. So just a quick way wanted to show you how question can be asked on these properties. Okay, now you can try these two questions. So here we are applying A and 0 to the XOR gate, another XOR gate where the output of this guy will be given with 0. Then again XOR gate 0, then it goes on and on for n gates. Then what will be the output? Another one is instead of using XOR gate, we are using XNOR gate. Okay, and the rest of the question is similar. And number of gates, what will be the output? So you can try your own, you know the concept now. So I'll do it. So if A and 0 are XORed, so what you can write is A 0 bar plus 0 A bar. This will give you A. Okay, so this is A. Now again you are XORing A and 0, so this is again A. Same concept. So even if you will have odd or even, doesn't matter, gates, the output will always be equal to A. Okay, in this case. And in this case if you will do it, you know that if you will XNOR A, XNOR we have to do, right, with 0, what you will get is A bar 0 bar plus A 0, that will be, this will be 0 and this will be A bar. Okay, so here it will be A bar. Now you are XORing A bar and 0, A bar and XNORing, then this will be A double bar 0 bar plus A bar 0, that will give you A. Okay, so output will be A. Then again output, then here you are XNORing A and 0, so the output here will be A bar. So what you can conclude is when n is odd, the output will be A bar, and if n is even, the output will be A. Okay, so that is just a simple question. You can try on your own. Just wanted to give you a feel.